So the area model of multiplication looks weird to those of us who were taught the traditional algorithm. Let me explain it really briefly. Here we have 35 times 12. And we know that 35 is 30 plus 5. And we know that 12 is 10 plus 2. We're going to multiply these two numbers. We put it in a grid like this as if it were the floor plan of a house. And this house has 4 rooms, and we need to find the area of each room. This room is 30 by 10, so 10 times 30 is 300. The area of that part of the floor plan would be 300. The area of this part of the floor plan would be 10 times 5. 10 times 5 is 50. The area of this part of the floor plan would be 2 times 30, so that would be 60. And the area of this part of the floor plan would be 2 times 5, which is 10. And then the area of the top 2 pieces of this model would be 300 plus 50, which is 350. And the area of these 2 pieces together would be 60 plus 10, which is 70. And so the area of the whole thing would be 420. And a lot of people commented that, oh, this is just so confusing. Oh, this is just so much work. And I just wanted to take a moment and show that it's the exact same thing that we do when we do the traditional algorithm. So let me show that to you. Here we have 35 times 12, except we're not going to do it that way. We're going to do it this way. And normally we would do 2 times 5 is 10, carry the 1. 2 times 3 is 6, plus 1 is 7. Move over, 1 times 5 is 5. 1 times 3 is 3. And then we would add these together, 0, 12, carry the 1, 4, 420. So we can see that we get the same answer. We still have the 420, and this is a 420. And we even have some of the same pieces parts. Here's the 70. And there's a 70. And here's a 35. And this is a 350. But how come this one's 35 and this one's 350? Well, it is 35. It looks like a 35, but it's in the wrong place to be 35. It's moved over one whole place. So this is the ones column, and it has a placeholder 0 in it, which a lot of us just don't even put anymore. And I've gotten into the habit of actually putting an X in there. So it is 350, and over here we have a 350. But what about all these other squares? I don't see those in it. Well, they're there. You remember when I said 5 times 2 is 10, carry the 1? Well, here's the 5 times 2 is 10 box over here. And then I said 3 times 2 is 6 plus 1 is 7, but it's not really a 3. It's in the wrong place value spot to be a 3. It's actually in the 10 spot, which means it's 3 groups of 10. So that's really 30 that we're multiplying by 2. And 30 times 2 is 60, which is right there. And then we end up adding those together, doing it the fast way. The traditional algorithm was built for speed. This is built for understanding. There's the 70, 60 plus 10 is 70. That's where the 70 comes from. The new models, the new way of teaching math is all about the why behind the how. The traditional algorithm was to save time, to save paper, and get it done easily, efficiently, and repeatably correct every single time. So what about this 350 that looked like a 35 just a minute ago? Well, here we go 1 times 5. Well, that's not really a 1. That's one group of 10. So that's 10 times 5, which is 50. That's why that placeholder 0 is there. And I bet you if you ask a lot of people on the street, why do we move over one space? They'll be like, oh, it's just the way we always done it. I don't need to know why. If I get the right answer every time, why do I need to know the why? Well, the modern ways of teaching include the why. So here's the 50 for 10 times 5. And then this 1 times 3, it's not really a 1 times a 3. It's a 1 in the tens place, which is 10, and a 3 in the tens place, which is 30. 10 times 30 is 300. That's why this is in the third spot. It's in the 100 spot. And then we add our 1s, add our 10s, and add our regroup one group of 10, and we end up with 420, just like this model does. I hope that helps. I'll post another video about how this model can help you get into a concept in algebra. Bye for now.